Well, good afternoon, everyone. Thank you, Ian, for that introduction. It's really an honor to be here today for me. This is a fast-changing environment. BIM, go on the web, and I think I found about 5 definitions of what BIM refers to. So you know it's changing fast when no one's really sure what the actual acronym stands for. I've been with FARO Technologies for almost 11 years and been in 3D digitization modeling for about 15. So, but it's a fast-changing environment for all of us. So, it's great to see so many people that are actively involved in this environment. And I had the pleasure last night of meeting with some of the CanBIM management and understand that it's all a group of volunteers. And I think that's really great that you actually have people that are putting in their own time and energy and horsepower to pull this together, and I think it's absolutely amazing. So I'm going to probably over PowerPoint you, but I'm going to mix it up with, I did do a quick scan of the room and pull some data in and show some live stuff. I see my slides are going to be a bit cut off, but that should be all right. So I don't know how great the graphics are going to show up here on some of these scan images, but I wanted to sort of just kick off. This is a set of scans that was done in the UK just recently, actually, by one of our customers. And I think it gives it's much clearer on my screen, of course, but gives a pretty good impression of, just what you can do in a pretty short amount of time. This is a sample of some external and interior scans done on it's a fairly famous Royal Albert Hall in the UK. So this is a fly-through that was done using Point Tools software, and as I understand, there was about 100 scans involved. And I won't go through the whole thing. It runs for a few minutes, but it's pretty easy to Google it up if you want to see it in its entirety. It does go through some of the buildings as well, because the interior of the hall was scanned. And it's one thing that hasn't been talked on when I talk to people about BIM, and everyone's actually interested in the ROI and how quickly they can get their money back for investing in the hardware and the software and the training that's required. The visualization is often overlooked, and I think it's one of the key benefits and components that you get for free when you are doing scanning for other purposes. And it's a very powerful tool in the marketing, when you're dealing with your clients, your peers, or the public, when you're making presentations of existing and planned changes. It's much more powerful, in my opinion, to be able to do fly-throughs like that than it is to have 2D drawings, and a lot of the public aren't so familiar with that. So when you can kind of see what the actual plan changes are and integrate that with the existing, it's a very powerful presentation media. And you get it in the process of collecting your scans for your projects anyway. So like I said, I'm not going to do that whole slide because it takes a little while. I'm sure everyone in the room, if you're in the BIM world, are pretty familiar with laser scanning, but in a nutshell, there's a couple of different styles of laser scanners on the market that would be used in this market: time of flight and phase-based scanners. The ones FARO manufactures and develops are phase-based. They're both capable. Both have slightly different areas of where you would deploy them. Time of flight, typically slower, but longer range is kind of the way to think about that. And the phase-based tend to be a little bit more accurate. If you were noticing earlier, the scanner that I have here, pretty small, compact, and it scans out to about 120 meters. So for the BIM type of work, that's almost a perfect area. Here you can see it, just a panoramic view of a 360 scan. I get gonged. And this one was done in color. So typically, the way the color is done, it's not done simultaneous. It's done as a secondary operation, and I did that earlier here, and we'll hopefully show that live in a minute. But the power is that you get everything. So when you go out on a site and measure, often you hear people going back multiple times, because they didn't get something, or they overlooked something, or they didn't get access to something. It was too high up. They needed scaffolding and ladders and stuff. So the beauty of scanning is that you get everything in one shot, and you can work with that, knowing, confident that you can measure and model directly off the complete data set. That's just an example of a overview showing the picture where the scanner was, and then some of the positions. So the holes are the tripod locations on the lower picture there. So roughly 10 or 12 positions required to cover something that's reasonably large. And I might add, reasonably sparse, too. So if there's a congested environment that you're gathering information on, then you're going to need more positions, because it is a line-of-sight data acquisition device. So this particular device, plus or minus 2 millimeters, is pretty accurate for most architectural requirements. You do get a full 360. You can window that down if you don't need the ceiling or certain specific areas. And you get all kinds of details. So if you're doing as-builts for various reasons, sometimes you want to do it because it's historical and you want to maintain and preserve all the architectural detail in the change parts, or sometimes you just want to quickly create a Revit model and get that ready so that the plan changes can occur. So you've got all that data. So what do we see happening here? Well, lots of things have combined in the last few years, which I think is why you're seeing scanning and the permeation point clouds really growing quickly in the world of BIM. Obviously, computing power has come way down. I did steal a slide off of Popular Science last night, but nothing surprising really there. But the numbers were kind of staggering. That top left is hard to read, but it does say 10 quadrillion computations per second is kind of where we're at right now, which is an awful lot. There was another quote on that same website that said that the current generation of iPhone has as much computing power as anything available on the market in 1990, which is pretty overwhelming when you think about it. I'm still sticking with BlackBerry. And the other opposing line, of course, is that the cost of memory, which is very important for scanning, because as we probably all know, big point clouds tend to take up a lot of space. But the beauty is that the cost of that space is going down, and you probably got more memory on your phone than your first PC did. So that's another effect. And the cloud computing we keep hearing about is really happening out there, and that's tending to drive down costs as well for everybody. I mean, you've got all this computing power. I mean, if you added up all the computing power in this room in everybody's pocket and on their laptops that are all sitting idle at the moment, I mean, imagine if you could tap into that and start harnessing some of this power. It's really an overwhelming amount of resources that are untapped, and cloud computing is starting to take advantage of that. Hardware, lots of changes going on there too. Energio last week, or 2 weeks ago, Regal announced two new scanners. One of them is able to collect data 7 kilometers away. That's pretty long range. Leica introduced its new time of flight scanner, very high acquisition rates, good accuracies, much more expensive than the FARO. But you know, just a rapid, every year there's more hardware. It's almost like every time you flip open you know, and look at the news coming in. If it's not a software change or buyout, it's a hardware change. So it's a rapidly changing environment, and the hardware is getting better and better, and the prices are tending to come down. So that's a great thing. New relationships. There's all kinds going on. We're currently involved with one. FARO recently announced a partnership with Trimble. So Trimble is now going to be going to market with a FARO-developed scanner and selling into their core expertise in this marketplace, actually. So you'll be probably hearing more about that in the very short future. So we're pretty excited about that, because I'm sure Trimble's working on combining the technology and their software, and so it's just another example of what's going on. Hardware OEMing and that kind of thing. You've probably seen examples of this already, but I know at Energio, the FARO Labs group showed a couple. This was a prototype. I thought it was kind of funny looking, but I'll show it for a second or two here. They're ScanBot. So if I pause it there for a sec, you can see that there is a Connect 3D built into the base of this thing. You've probably all seen the indoor mobile mapping devices, which is what this is, an autonomous mobile mapping device with the scanner up top. So what that does is it semi-automates so this guy's following it around with an iPad, but the idea is that you can pick spots and it goes there, does the scans, and then registers all those scans automatically. So it's a big time saver. There's already some other products on the market. I think there was 5 or 6 at Energeo that are doing this automated indoor mobile mapping type thing. And on the software, it's moving even faster than the hardware. It's hard to keep up. And it's mainstream softwares, such as AutoCAD, a big player in this market, as you all know. Especially in the Revit world, it's almost synonymous with BIM these days. And the changes, only, 2 years ago, I think, when they first were able to import native point cloud data, and adding tools all the time. Rumors are that the purchase of the Alice Labs point cloud engine will probably be coming into the 2014 AutoCAD product line. We're all excited about that. Even way more capabilities. So, and all the players, similar announcements, taking massive point clouds and providing the tool sets that are needed and that have been missing to enable people to do the modeling that they require in a lot of your work environments. So these stronger tool sets and capabilities are making it even easier and faster and just possible to do it. Hybrid modeling, I had a little clip there, but I think I'm gonna run out of time, so I'm gonna skip a couple of these clips. But really just showing that mixture of CAD model data on top of the scan data. And that's a great, in many arenas, whether it's a piping environment, manufacturing where you've got a very busy environment and you want to change something, it's changing all the time. Automotive plants do it. In the traditional way, they could barely map out the facility by the time it had already changed. So this is a great tool to be able to mix the data sets and build directly off the points. Freeware is a funny one for me to put up, but I'm sure everyone's heard of Mesh Labs, Linux-based software out there. There's several companies that are actually taking advantage of freeware, and I'm almost embarrassed to say that FARO's participating in that now. But we just announced Scene CT, which you can, and I'm going to show this, but I'll speed it up. You can actually hook your game directly up and do scanning. So this was just announced a couple weeks ago. It's still sort of a beta thing, but if you've got one at home, you can download the software for free and scan away. And here you see an example of somebody just scanning, and you can see the scan data on the left. Had a customer of ours sent an email out shortly after this was released. He'd already scanned the interior of his car, forensics guy, and he was astounded at how accurate and how fast and easy it was. So why is freeware important? Well, those three things, the computing power, the trend in the hardware, which is better, cheaper, and the same thing in the software, much more capable, are all combining. It's at a great point in the industry. So you finally got the tool sets, you've got the memory that can handle it, and at a price point that makes sense. So that's really what's going on out there. And where is it used in BIM? There's a few areas. I mentioned the visualization, which I think is underutilized currently. Great tool for collaboration. You've got lots of large companies sharing data sets, lots of intercompany action going on. Good tools for sharing and getting to decisions faster when you've got issues. And estimating tool. We've got customers that are using the scan data early on in the process during their proposal stage, and then using that same data for design on later on. So you've already got the data, and the data acquisition time is fairly fast. So they maybe not do all the modeling and do all the work on the data set, but they can use it and get the dimensions and the things that they need to do an accurate and quick estimate. Obviously, the creation of as-built models, and we'll talk more about that. Class detection is another big area. And then verification. We've got more and more customers actually doing scans after they've done some construction and verifying back to the CAD model that, yes, it is conforming to what the client wants. So I'm going to step through pretty fast on a couple of these because I've got too many slides. But here you see a facade, a bunch of scans on the left. This is the scene software. They were interested in creating a CAD model in this case. There was a fair bit of architectural detail that they wanted to capture. And I was just showing, this is actually AutoCAD architecture, where they're developing the model and showing some of the detail work. And that's an example. So this is a 2D cross-section going the other way, perpendicular through the wall. But what's good is you can actually capture that unique profile that was maybe handmade, who knows when, and use that as a basis to create or manufacture the replacement ones. This is where I usually stay. Just kidding. This was another facade study. So there's the picture and then the scan data on the right. So notice you are capturing from the ground level quite a bit of data, even reasonably high up. And obviously your angle is impacting what you can capture at the very top. And there you see the overlay of the development of the CAD model with some detail. Again, a lot of detail was required on this project. Hard to measure that. I can't imagine how else you would do it. So they did a complete exterior model. And they were asked at the same time, there was a couple areas of concerns on that same facade where there was some deterioration, and they wanted to do an analysis. And here you can see, that's actually the intensity image. That's not a picture, that's the actual scan data. So you get a lot of detail. And they were able to show, where it was outboard and where it was inboard. And you can see quite a deviation on that wall. So the typical BIM application would be an interior space that's gutted, ready to go. It's all about getting the information fast and to be able to use quickly. There's an overview of that space. You can see relatively few scans were required to capture a large environment. And again, it's a bit hard to see some of the detail here, but this is a full architectural drawing was made of that space. And you can see there is some mixture of the scan data and the architectural drawing here. So that you can see the columns. I don't know if they're hard to see, but there's a bigger picture on the bottom right there. So that's sort of a top view looking down of the I-beam and the cross-beam scan data, and then that, I don't know if you can see that kind of the purple around that, but the box that was used. So you get a lot of information that enables you to accurately capture what's going on and get all the details you see there. This is a parking lot where the contractor ripped out all the, what's the word, the suspended ceiling. And when they went back in to do the job, they realized they had all kinds of unexpected things sticking down in the way, and they didn't know where to put the hangers. So they decided to scan it and get a very quick way to sort out where they were going to put their hangers and speed the process of the job. This one was used, I talked earlier about the automatic targetless stuff. Here you can see they used targets to register the multiple scans together. Again, a fairly large area, quickly got all the information they needed. There's an image of a bigger tripod than the one I carry around. Quite common for contractors that are doing MEP work to want to gather all the information up above the ceiling tiles where all the infrastructural stuff is. So guys are using tripods like that and punching them up and then taking scans of congested, messy environments And that way they can detail in the CAD and do the routing of whatever's being replaced or new that's being put into that space. So the other one we hear about a lot is the clash detection. And if you read some of the BIM write-ups, that's one that a lot of guys seem to be able to show a very definitive ROI because you discover so many clashes. If you would have discovered that during the construction phase, there's just headaches and time wasters. So if you can discover and eradicate those ahead of time, then you're going to enjoy a large cost savings and probably a big time savings. So there's a picture of another interior space, the scan, the Revit model that was created and then overlaid onto that scan. So if you look on the top right, in the blue, there's a HVAC duct going right through the steel beam, which is not good. Anyway, those are the types of clashes we're talking about. So if you can discover that early on in your design phase and reroute, and that reroute may impact all the other guys that are doing their work. And what I'm told is that there's contractors that now confidently are deploying multiple, like you don't have to go linearly anymore. Have the HVAC guys and then the electrician and then your plumbers. It's you can do it all at once because you know it's all going to fit. So you can get some overlap in time and compress, which is kind of against the grain of what has been done in many cases previously. There you can see it's been rerouted. I forget the number here. There was some tremendous number of clashes that were discovered before they went on site. There again, you can see that light blue on the right being rerouted to go around. This is similar to one of the ones I already showed. The facade study, getting a quick inboard, outboard. A lot of people seem to be checking into these for multiple reasons. One is there's some safety concerns. One is if you're doing additional work, you need to understand exactly what's going on and how that's going to be impacted. And have you impacted after the fact? So maybe you did some work and then you do your study and you realize it's the same as it was or it's changed. So being able to do these deviation maps is a very, very nice visualization tool to understand exactly what's going on before, during, and after project. This one is a floor flatness one, and it was the Kaiser Medical Center. And I stole some stuff here from the McCarthy presentation at SPAR, so I want to give them credit for that in case there's somebody in the room from McCarthy. But I thought it was a good example to show. And it wasn't our gear that was used, so. Just how they traditionally were measuring floor flatness, doing a grid layout and manually taking the reference points to ensure everything was, to understand either what the existing was or that it met the criteria after the fact. So they got the report, and you can see their snarky comment on the bottom here, exceeded project requirements. Great, right. So it did meet the requirements. However, they went back with a scanner, scanned that same environment, and mapped the contours right onto the building here. And several areas were not discovered where they had high and low. So they needed to pour and grind in areas where that they wouldn't have caught using traditional methods, I guess, is essentially what's going on there. So this is what they claimed. Pretty substantial reduction in the scheduling time and a pretty equivalent substantial savings in cost. So that's a good ROI right there. We are accepting POs after this presentation. Just kidding. This is a similar idea, and this was actually capturing the steel before and after the concrete was poured to try and understand what changed, what happened, was it within the limitations or the spec. And in this case, they were able to do a full full map showing the sag from pouring that concrete. So this is actually a view of looking up at the underneath at the ceiling, right? So quite a few changes. These were, it's hard for you to see, but the ones in green are more than 3/4 of an inch deviation. So again, less quantified here, but a substantial savings. I mean, I don't know how else you would measure that. Maybe manually, you'd have to measure each beam, several locations, and a before and after, which would not be very easy to do. This is another one I borrowed, but and it's hard to read, but it showed a substantial savings in time compression. And Pepper Construction, I'm sure you've all heard of, did a major project and had a very, very short timeline to do it. And they also had to, it was a whole floor of this hospital, and they weren't able to shut down the hospital. Like, they had to keep everything else going. So there was a number of constraints, and it was also in a very congested area downtown Chicago. So all the difficulties that could be there were there. And actually, if you haven't already checked this study out, take the time to do it. I think you can get it openly on the web, if not through the SPAR website. But it's actually a great read and really strong business case for using BIM overall. I'm only pulling out the scanning-related portion of the BIM, but there's a whole bunch of other stuff in there. So here you can see the scan of an area they picked out, and I just borrowed this again. The actual model that was built, the MEP stuff, and then actually after the build, when the floor was completed. And what's interesting to note here is you can see the traditional timelines that were mapped out. And again, this is just a portion. There was a whole other area, but I'm just extracted the scan data stuff. So you can see, just from the scan, the shortest little blip on the bottom one is the actual time to do the scan. But you can see they got the drawings out the door much faster. The fab was done much earlier, and they could begin the installation much sooner in the process. And powerful quote at the bottom there, too. 839 clashes were uncovered prior to going in. The font's too small, and we'll bother with that. But again, I would encourage you, if you haven't already read that business case for BIM, it's an excellent read. Now, thank you.